Traditional transportation management systems function as static repositories. They require human operators to manually parse incoming orders, calculate routing parameters, and audit driver telemetry. This architecture operates on an event-driven pipeline, where a single piece of incoming data triggers a cascading chain of automated reactions across the network. This is TMS 3.0, managed by 5 specialized AI agents. Instead of manual data entry, these nodes autonomously trigger one another. One agent's output becomes the next's directive. We trace this by following a container, from the initial delivery order to automated profit calculation. By replacing a passive database with an active, multi-agent orchestration, the system removes the administrative friction typically found in the logistics lifecycle. The lifecycle begins at the point of origin, managed by the data integration agent. When a client submits an unstructured delivery order, the agent instantly structures key metrics like the bill of lading, container number, and location codes. If it detects a low-confidence extraction, a split-view interface prompts an operator to quickly verify data. With the data structured, the agent moves to the background, continuously querying the DrayDog API. The workflow only advances the moment the API confirms the vessel is discharged and all customs holds are cleared. This combination of automated ingestion and continuous API monitoring turns a passive waiting period into an instantaneous operational trigger. That trigger activates the customer interaction layer, which is where manual order processing often slows down. TMS 3.0 deploys the customer portal agent to handle this phase, replacing static scheduling interfaces with a language-driven model. When a client enters a scheduling request in natural language, the underlying large language model interprets the intent and immediately renders a functional calendar widget for the user to confirm dates. If a user asks for an air ride chassis, the agent parses the context and automatically generates a structured special request ticket within the internal system. Utilizing generative UI driven by an LLM removes the manual intake phase, mapping unstructured customer intent directly to the internal dispatch logic. Once the schedule is locked, the data hits the 3D cube core and the dispatching agent. The agent takes the monolithic job and fractures it into discrete operational legs: the load, the drop, and the empty return. To find the optimal driver, the agent multiplies total miles by cost per mile and adds a location difficulty score. Weighting fixed costs by the historical difficulty of the yard ensures the system accounts for predictable delays. This recommendation appears on the dispatcher's job board as faint ghost text, outlining the ideal driver pairing and their current availability. Assigning this optimal route requires a single click, which instantly transmits the directive to the driver's mobile device. This process replaces dispatcher intuition with a solvable mathematical equation, combining cost efficiency parameters and historical facility data. As the physical truck begins its route and crosses the geofence parameter into the terminal, the system moves from planning logic to live execution. The live tracking agent now continuously cross-references live GPS telemetry from Samsara hardware against predetermined map geofences. When a truck enters a designated live unloading geofence, the internal progress bar automatically shifts to indicate active operation. To manage exceptions, the agent filters out normal operations, highlighting only the units currently violating their expected times of arrival. The moment a geofence exit is recorded, the agent executes its relay logic, autonomously queuing the subsequent leg of the trip for the next driver. This tracking continues through the empty return phase. Once the physical yard return is verified and the proof of delivery is uploaded, the job is instantly cleared from the active dispatch board. Real-time geofence integration handles the physical progress tracking, reserving the dispatcher's bandwidth for true operational anomalies. The focus now shifts from the physical yard to the back-office settlement phase, handled by the billing agent. Because the data was validated in real time by the tracking agent, it instantly populates the accounts payable and receivable tables, including specific line items for demurrage or wait time. Variables that typically require manual auditing, like free day overages or terminal waits, are now proven by telemetry. The verified fee traces directly back to a definitive GPS timestamp. With all operational cost verified, the agent calculates the exact gross profit for the shipment in real time. The finalized invoice package, along with all verified telemetry documents, is automatically sent to the customer's portal for closing. Financial settlement delays are minimized when physical operational events are structurally encoded and verified by geofences at the moment they occur. The closed shipment data is transferred to persistent storage, managed by the asset and payroll agent. This agent checks the initial dispatch logic against actual payroll requirements and uses accumulated GPS mileage to schedule predictive asset maintenance. Managers can interact with this data by submitting a natural language prompt, such as show average margin and terminal wait times for Maersk this month. The system renders a specific data chart instantly. Because every operational step was verified at the source, these on-demand generative widgets provide accurate insights without the need for manual report generation. By utilizing sequential AI agents to structure and verify data at its physical point of origin, TMS 3.0 automates the logistics back office, from the initial order to the final ledger.